Hello everyone, in this video let us solve a problem on convolution integral. So here the question is you have to find out the output of the LTI system when input and impulse response of the system is given. So the input which is given here is x of t, which is equal to e to the power of minus 3t into u of t minus u of t minus 2, and h of t which is given here is e to the power of minus t u of t. So you all know about the convolution integral, that is y of t is equal to integral, that is from minus infinity to infinity, x of tau into h of t minus tau d tau. Right? This is a convolution integral which you all know. So now what I will do is I will be writing this x of t in terms of tau. It is nothing but you are just replacing t by a variable tau. So here this becomes x of tau, that is equal to e to the power minus 3 tau u of tau minus u of tau minus 2. So how can you simplify this? You know u of t is nothing but it starts from 0 and it goes on till infinity, right? So this is your u of t. What is u of t minus 2? It will start from 2 and it ends till infinity, right? So this is 0 and this is 2. So when you subtract this u of t minus 2 from u of t, you are going to get only this particular portion, right? This particular portion. So that will be 0 to 2. Okay, this is 1 and this will be your u of t minus u of t minus 2. So now if I multiply this with the exponential, that is e to the power of minus 3t. So this is your e to the power of minus 3t. So this is equal to 1. This magnitude is equal to 1. So now if I multiply this, I am going to get only this portion. So I can erase the remaining here, right? So I can erase this. So this is my x of t, right? This is my x of t. So that is nothing but it is x of tau. So here I will give the variable tau. Okay. So in the next page I will write, this is my x of tau. This is 0. This is 0. This is 2. This is 1. Okay. So this is nothing but e to the power of minus 3 tau u of tau minus u of tau minus 2. Okay. This is the variable tau. Okay, so this is my x of tau. So next, what is this h of t? So to get this h of t minus tau, we have to do some modifications, right? So you have h of t. What I will do is I will replace the variable, that is by from t I am changing it to tau. After this, I have to get this h of t minus tau. So to get this, what I will do, I will reverse this. Okay, I will get minus tau, h of minus tau. This is by reversing, that is a mirror image. Next, what I will do is I will be shifting this, whatever signal which is obtained, I will be shifting it towards right by t units. That is, tau will be replaced by tau minus t. Tau minus t is nothing but replacing it by t units rightwards, right? So here I can replace this minus as it is. Instead of tau, I am taking tau minus t. So this will be h of minus tau plus t. Okay, so this is the same thing. So this is the procedure that we are going to follow to get the h of t minus tau. H of t minus tau. So what is h of t? That is e to the power of minus t ut. So now h of tau will be e to the power of minus tau u of tau. Right? So now what I will do, I will reverse it, h of minus tau. So here it will be h e to the power of tau u of minus tau. That will be this signal, right? Something like this. Okay. So now what I will do, I will shift it by t units rightwards. That means I can start from here, right? I can start from here. So this will be a h of t minus tau. This is h of t minus tau. Okay, so we got two signals. So one is this 0 to 2. This is 1. This is x of tau. What is h of t minus tau? Here somewhere it is t, right? It is t. Why it is t? Because see, it was 0. So if I am shifting it towards right by t units, 0 plus t, so this becomes t. Okay, so now this is t. So here I am going to get like this. So this is my h of t minus tau. So now we will take different cases to find out y of t. Why? Why we are going to take the different cases? Because we have seen the integral, that is a convolution integral. It is a multiplication of these two particular signals, right? It is a multiplication of these two signals. So this is a variable t now. So if it is less than 0, I will be getting some value for y of t. If it is greater than 0, and if it is less than 2, I am going to get a different value. If it is greater than 2, I am going to get a different value, because the overlapping regions will be different for these three cases. Okay, so suppose I am taking the first case, that is if it is less than 0, that means if this t, see here, this is my x of tau. So now if my t comes here, okay, if it is less than 0, somewhere here, where there is there any overlapping region between these two? No, there is no overlapping region. So now I can write y of t is equal to 0. This is the first case. Okay, in the second case, what I will do is, I will place this t somewhere in between 0 and 2. So t, it should be greater than or equal to 0 and it should be less than 2. So this is my second condition. So here this is the same thing. What I have done, that I have placed h of t minus tau somewhere in between 0 and 2. Okay, so here what is the overlapping region? So this will be the overlapping region till t, right? So what will be your convolution integral then? It will be not from minus infinity to infinity, it will be from 0 to t, because in the overlapping region I have 0 to t. So I will write it as it is. Now I will write x of tau, because x of tau into h of t minus tau. So what is this x of tau? It will be e to the power of minus 3 tau. This is e to the power of minus 3 tau, right? Into h of tau. What is this? H of t minus tau. What is that value? You can see here. It is e to the power of t u of minus tau. And now if I replace this, okay, it becomes, I will be replacing this tau by tau minus t. So this is tau minus t and this is u of t minus tau. So tau minus t, e to the power of tau minus t. Okay, into d tau. So now can you solve this particular integral? See, you are going to integrate it with respect to tau. So what I will do is, I will take this e to the power of minus t outside, because it's not going to make any difference in the integral. So now we have 0 to t, e to the power of minus 3 tau and tau. So it will be e to the power of minus 3 tau plus tau, e to the power of minus 2 tau, d tau. Okay, so what will be the value for this now? E to the power of minus t into e to the power of minus 2 tau divided by minus 2. Okay, and now this will be from 0 and t. Okay, so now what I will do is, I will write minus 1 by 2 e to the power of minus t as it is. And next what I will do, e to the power of minus 2 tau. And here this will be t and 0. So now minus 1 by 2 e to the power of minus t. So this will be e to the power of minus 2t minus 1. So now I will write 1 by 2 e to the power of minus t. And this one I will take minus inside. So 1 minus e to the power of minus 2t. Okay, so this will be the value of y of t when t is between 2 and 0. When this is the condition, we are going to get this value for y of t. So now what I will do is, I will place this t outside this, that is greater than 2, that is the third condition. T greater than 2, that is the third condition. In this case, if this t is outside somewhere here, so that will be, this will be the overlapping region. Total x of t will be included. So in the integral, you are not going to get 0 to t, but you will be getting 0 to 2, because that is the overlapping region. So that will be 0 to 2. And now everything is same. E to the power of minus 3 tau, e to the power of t, tau minus t, e to the power of tau minus t into d tau. Everything is same. Just in place of this t, we are going to write 2 and 0. So now solve this. Minus 1 by 2 e to the power of minus t. Here we are going to get e to the power of minus 4 minus 1. So this will be 1 by 2 e to the power of minus t. Here I am going to get 1 minus e to the power of minus 4. Okay. So this will be for the value t greater than 2. So these are the different values of y of t.